Hello friends, I am Yugen Kulkarni and we are studying the chapter Current Electricity from 12th Physics. In this video, we are going to study the concept of Wheatstone bridge. So, what is the Wheatstone bridge? It is the apparatus or it is the device or instrument which is used to find out the unknown resistance. Now in this picture you can see the real image of trial network of Wheatstone bridge. So these are called arms of the Wheatstone bridge, and here we connect two known resistances, and here in between these two junctions we connect a known resistance, and in another two junctions we connect the variable resistor, and in these two junctions we attach the galvanometer. This is the animation of connected Wheatstone bridge. So here this is the battery or the voltage supply. This is the flowing current through this, and this arrangement is called Wheatstone bridge. So this Wheatstone bridge consists of 1, 2, 3 and 4 resistances, out of which 1 and 2 are known resistances, and we have to find out this unknown resistance using this variable resistance. So variable resistance means we can change the resistor using the knob. Here is the galvanometer. We can see here the circuit diagram of Wheatstone bridge. So this is a battery, this is key, and the current is flowing in this direction. Now here these are 4 resistances. So in general we can connect any 4 resistances. We may know the values of all resistances. So in this picture we can see P, Q, R and S are 4 resistances, and here is a galvanometer. So the current from battery moves like this and it reaches to this point. This is junction A, and the current divides into two different currents, I1 and I2. Now again at this junction B, this current again splits into two. The current through galvanometer is called Ig. I1 is the current flowing through this arm and Ig is going in this. So the remaining current will be I1 minus Ig, which will be flow through resistance Q. Then here is a junction C, and the current from Ig and current Ig from galvanometer and current I2 from S will combine at D, and so the current through resistance R is I2 plus Ig, and again these currents will combine here to give again I1 plus I2, that is equal to I. So Ig and Ig will cancel out here. Now we will solve some equations for this using Kirchhoff's voltage law and current law. So using Kirchhoff's current law we can write I1 plus I2, which we have already used. I1 plus I2 is equal to I, right? So at this junction A we can write this. Now we can call this as equation number 1. Now we can solve for this loop A, B, D and again A. For this first loop we can solve Kirchhoff's voltage law. So if we go from A to B in this direction, the direction of the current is same. So the potential difference we will write will be negative, and it is the product of current and resistance. So this will be I1 into P, that is the resistance through A to B. Now again we will go from B to D. In this case also the direction of current and our direction is the same, so we will write negative. Now here it will be, the current will be Ig, Ig will be the current, and resistance of galvanometer is also G. So let's say this is G. Now in this case again, if we are going from D to A, then the direction of current and our direction is opposite. So we can write this as positive, and the amount of current is equal to I2 into the resistance is equal to Is. The resistance is equal to S. And now this must be equal to 0. So this is the second equation. Now similarly we can solve for this BCDB loop, right? So for this loop also we can write equation. I will write here. So for this loop we can get the equation minus I1 minus Ig. So this is bracketed term is negative because we are moving in the direction of current. Now we are gone from B to C. Now the resistance is Q here, so we will multiply it here with Q plus C to D. So when we are going from C to D, the resistance is R, and the direction of current and our direction is opposite, so we will write plus, and this current is equal to I2 plus Ig. Now again from D to B, when we are moving in the direction opposite to that of the current. So here also we will get plus Ig into G, and this will be equal to 0. Now if we consider the current through this galvanometer, that is Ig is equal to 0, means what? The current is not splitting here. The current from A to B is moving directly from B to C, and it is not moving from B to G. Then we can cancel out Ig from all these two equations, equation number 2 and equation number 3. So this term will get cancelled, this term will get cancelled, and this term will also get cancelled. This term will also get cancelled. From equation number 2 and 3 we get, when we put Ig equal to 0, we will get minus I1p plus I2s is equal to 0. And if we rearrange this, we can get I1p is equal to I2s. Name this equation number 4. Now from equation 3, when we put Ig equal to 0, we will get minus I1q plus I2r is equal to 0. Now rearranging, we will get I1q equal to I2r. Name this equation number 5. Now dividing equation number 4 and 5, what we will get? LHS will be get divided by LHS, and RHS will get divided by RHS. So this I1 and this I1 will get cancelled. Similarly this I2 and this I2 will get cancelled. So what we are getting is P divided by Q is equal to S divided by R. Now remember, this is the condition for Wheatstone bridge. When we have to find out the unknown resistance, we also find out such condition that the ratios of this resistors will be the same. Now let's look again the diagram. From the equations we got P, this is P, this is the resistance P, divided by this Q is equal to S divided by R. Now we can put the unknown resistance in place of S, and we can arrange here the variable resistor, so that we can keep the P by Q ratio same. So we will know what is the P by Q ratio, and then accordingly we can adjust R. So how will we know that the ratio is equal? We know this is the condition when there is no current flowing through the galvanometer. So we will adjust the resistance such that the current through Ig, that is, there will be no deflection because there is no current through galvanometer. So the principle of Wheatstone bridge is to find out the resistance R such way that The current through galvanometer will become 0, and hence at that point, at that condition, we can calculate S using the formula P by Q is equal to S by R.